Yeah, another type of problem that looks sort of like this one. And we're gonna let her speak a little bit, and then I'll fill in um, as we go.
In this problem, you will solve for a variable and use substitution. What is the solution of the system? Use substitution. The first equation in the system is 3 times y plus 4 times x equals 14. The second equation is negative 2 times x plus y equals negative 3.
So what you might notice is a little bit different here is that it's not in slope intercept form. Neither one is in slope intercept form, and neither one is currently being solved for like y or x.
What do you know? Neither equation is solved for one of the variables. What do you need? You need the solution of the system. So what's your plan? Solve one of the equations for one of the variables. Then use the substitution method to find the solution of the system.
So essentially what we're going to do is we're going to solve for either x or y. And hopefully one of the two equations is going to be easier than the other one to solve for x or y.
Step 1. Solve one of the equations for one of the variables. Which variable should you solve for?
Well, she's going to tell you in a second, but this y is already by itself, so it'd be really easy just to add 2x to both sides, and then you'd know what y was equal to.
If one equation has a variable with a coefficient of 1 or negative 1, solve for that variable. It is generally easier to solve for a variable with a coefficient of 1 or negative 1. Write the second equation.
So when she says a coefficient of 1 or negative 1, she means that this y is a coefficient of 1 or negative 1, right? It just we know that there's supposed to be a 1 there, or it's understood that there's a 1 there. And that's all she's saying. So we'll continue.
Add 2 times x to each side. Simplify.
So all we did was we added 2x to both sides, and then when we did that, we were left with y equals 2x minus 3. And this is going to allow us to substitute this value in to this equation up here for where we see the y, right?
For step 2, substitute 2 times x minus 3 for y in the other equation and solve for x. Write the first equation. Substitute 2 times x minus 3 for y. Use parentheses.
We did that because we know, again, that we figured out that y is equal to 2x minus 3. So we plugged that 2x minus 3 in for the spot right here where we saw the y is. And again, what, what this gives us is the opportunity to only have x's in our equation, which means we can then solve for x.
Now use the distributive property. Simplify.
Hopefully you're able to follow along with that. We distributed the 3 through here, so 3 times 2x is 6x, 3 times negative 3 is negative 9, and then we just combined the 6x and the 4x for 10x, and then kept the negative 9.
Add 9 to each side. Divide each side by 10.
Well, here it is. Somebody in one of the classes asked if we'd ever have decimals, and there it is. Welcome to decimals.
Step 3. Substitute 2 3/10 for x in either equation and solve for y. Write either equation.
So again, it doesn't matter which one you plug the 2.3 into. I would say always look for the one that's going to be the easiest to plug it into. It'll just make your life easier.
Substitute 2 3/10 for x. Simplify. Add 4 6/10 to each side. The solution is the ordered pair 2 3/10, 1 6/10. Now it's your turn.
I'm guessing from seeing that seeing that there comes up with two decimals, it doesn't instill a lot of confidence that this is going to be easy. I know there's a lot of steps involved. I think that it's important just to give it a shot, and we'll do a bunch of these. And I think that once we do a fair number of them, that hopefully it'll become you'll form good habits in solving these, and we'll be able to do it. So here is the second got it problem that I'll be expecting to see in the next class. So give it a shot. See what you can come up with for each one of the, or using substitution to solve for this. Pause it. Do it on a piece of paper, probably on the same piece of paper that you did the first problem, and we'll come back in a second and we'll see what you got. Here are a few answer choices. Maybe one of yours looked like this. Hopefully it looked like one of them, or at least you got one of them right, of the two points. But these are kind of scary looking. We'll see what the correct answer is, and it's this one, right? So let's check out the solution and see what we got here. So it says solve one of the equations for one of the variables. So that's what we did. We're looking for the one that's going to be easiest to solve. It's obviously going to be this one. It's going to be the easiest one to solve for either x or y, because all we need to do here is subtract 3x from both sides. So we've done that here, and we know now that x is equal to -7 minus 3y. We're going to substitute -7 minus 3y in for x into the other equation. Doesn't make any sense to plug it into the one we use, because that's the one we use to solve for x. And here's the second equation, or sorry, the first equation, 6y plus 5x equals 8. And we know that x is -7 minus 3y, so we replace the x with -7 minus 3y, and then we solve. We're going to have to do distributive property here, -35, -15y. We can combine the 6 and the -15y for -9y. The 35 stays by itself. I will then add 35 to both sides. 35 and 8 is 43, and then I can just divide both sides by 9, which gives me -4 and 7 9, so 43 over 9, -43 over 9. And now that I know that y is equal to -43 over 9, I can substitute that in for y. So we can write into either equation. We'll just go back to this equation. It doesn't matter which one we plugged it into, but here we go. X plus 3y, replacing the y with -43 over 9. Distribute 3 times that, so we're going to get -43 over 3, because the 3 and the 9 cross cancel out. And then we can add 43 over 9 to both sides. You have to come up with a common denominator for this. I don't intend to ever give you one this complicated. I'm more concerned with the process and not your work with fractions and decimals. And when you do solve that, you're going to get 22 over 3, which is 7 1/3. If the numbers here are intimidating, don't stress about the numbers. I'm more concerned with the process of solving for either x or y and then plugging the value in, or the mathematical phrase to help you solve it. Okay. This is I wanted to be able to show you a couple of these before we met next time, so you understood how we would go about doing this, solving these mathematically as opposed to graphically. And we'll do some work with these, and we'll certainly start with some that are much simpler than this. But as long as you were able to get a little ways in this process, I think that we are well on our way. Okay, so we'll talk about this next time in class.